Hello, my name is Emily Gibson. I am going to be simulating a 6th grade math lesson regarding perimeter and area. So we would be doing a review lesson with perimeter and area just to kind of set the stage prior to instructing surface area and volume. Okay, so let's go ahead and get started here. We are going to just start with our top section here, looking at irregular shapes. If we were asked to find the perimeter and the area of these three shapes, how could we do that? Let's do number one. I'll show you how to do number one. Remember, to find the perimeter of a shape, you essentially are looking at how many cubes would be needed to fill in the length or the outside of the shape. So we can essentially just outline them and count. So there's 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. So my perimeter of this first irregular shape is 24 units. What if I was asked to find the area of this shape? Remember, the area is how much it takes to fill in the shape. So let's count the squares that are inside of this shape. We would have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So what's my area? It would be 20 units. Okay. So now that I showed you how to do the first one, let's do the second one together. So again, if I'm asked to find the perimeter of this irregular shape, we're going to count along the outside of the shape and figure out how many units it would take for the length of the outside. So we have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28. So what's my perimeter? My perimeter would be 28 units. Okay, and then how can I find the area? Again, it's the inside of the shape, so how many squares fill up the inside? So right here is 4, 8, 10, 12, 16, 20. So my area would be 20 units again. Okay, now that we've watched me do one, we've done one together, I'm gonna have the class go ahead and try that independently. We would obviously review their answers on that one before we move on to more regular shapes without the grid, okay? So once we review our answer, let's go ahead and take a look at the shapes down below. We're still looking for the perimeter and the area of these shapes, except for it's a little bit harder because I don't have square units. So for this one, you would need formulas. I would differentiate that by providing a formula sheet to each student, just as a visual to have, something along this line that just kind of reviews what formulas are there to find area and perimeter. Okay, so let's start with our square. I'm going to show you how we're going to find the perimeter and the area of the square. Remember, perimeter is the outside of the shape. So to figure out the perimeter of this square, we could essentially just add all 4 of the sides together. So for instance, if this side length is 20, this side length is also 20. So what would 20 plus 20 be? You'd be working with the number 40, okay? What about this side length is 15? This side length would also be 15. So together that would equal 30. If we add up 40 and 30, we're left with 70. That gives me my perimeter. My perimeter is 70 units. How can I find my area? Again, you can reference your formula sheet. The area of a square is length times width. So I'm going to take length, which is 20, times my width, which is 15. What is 20 times 15? Well, 5 times 0 would be 0. 5 times 2 is 10. Oops, I guess I could just write that. Now that I'm done with my 5, I'm moving on to my 1, right? 1 times 0. First, I need my placeholder. Now I do. 1 times 0 is 0. 1 times 2 is 2. If we add those together, that gives me my area of 300 units. 300 units. Okay. Now that you just watched me do the first one by myself, we're gonna do the second shape together here. This one we cannot solve for area because we're missing an important measurement here, which would be the height. if I had the height, we could solve for the area here, but I'm not given the height, so we're just gonna solve for the perimeter. Okay, you'll notice that the bottom of my base is 10 units. So let's add 10 units plus the top side is 7, plus my side along there is 6, obviously leaving this side also is 6. So let's add those up. Well, 6 plus 6 is 12. What is 12 plus 7? 29. 2 plus 1 is 3. So my perimeter would be 39 units. Okay, now that I showed you how to do one, we did one together, I would have the class go ahead and solve that independently. We would obviously then review answers. Okay, we're gonna kind of move on a little bit from these types of problems, and we're gonna take a look at a word problem next. So we would do a couple of these together. We're just gonna skip over the top part of this sheet because it's having you solve for the missing length. I feel as though it would be important just to cover and make sure students are understanding perimeter and area first before we get into solving for those missing side lengths. But it's definitely nice to incorporate some word problems. So we're gonna do 3 word problems. I'll do one myself, we would do one together, and then I would have them try that one independently. So let's go ahead and do that. So first one says, all fenced in. Help, puppy Ruby. I'm gonna read from my paper here. Sorry, it's a little hard to read from there. All right, okay. Puppy Ruby keeps getting out of the yard. The dimensions of her rectangular yard, okay, well, we know what shape we're working with. We're working with a rectangle. I like to just draw that so we can keep that in mind as we read the rest of the clues. The dimensions of her rectangular yard are 25 feet by 50 feet. Obviously 25 being the shorter side, 50 being the longer side. Draw a picture, we got that, to show the yard and determine how many feet of fencing Ruby will need to be kept in. Okay, so first off, we need to figure out if we are using area or perimeter. Well, picture a fence, right? Does the fence fill in this entire thing, or does the fence just go around the backyard? The fence would go around the backyard, therefore I'm solving for perimeter, okay? Let's find the perimeter of this rectangle. Remember, to find the perimeter, we add all 4 side lengths, okay? My longer side is 50, obviously making this side 50. What is 50 plus 50? We're left with 100. 25 is my shorter side with another 25. Add those together, that's 50. Adding up all 4 side lengths, I would need 140 feet, or 150 feet, excuse me, of fencing to fence Ruby's yard in, okay? Carrying on with the lesson, we would do the second word problem together, and then I would have students solve that one independently. Obviously, we would review that answer as a class just to make sure everyone's on the same page. Once we review those, we would move on here so I can essentially assess student understanding. This is how I would assess student understanding with more of an independent, I would allow maybe partners or small groups dependent upon the class size, show what you know sort of thing, okay? So in this problem, essentially it says you have been tasked with designing a new playground. So students would be pretty interested in that. A lot of my students right now like to draw and design things themselves. So this would first off be an attention getter and make them want to do this. So you're designed to design a playground for the new school. The space that you have is 40 feet by 50 feet, which is this space right here, okay? They want you to draw a rectangle to represent your space below. 1 unit would equal to 5 feet. Okay, then it goes through 2 different parts. That's asking them to design certain things within that playground where they would need to figure out their perimeter of their space and their area of their space. So not only is it intriguing and fun for students to complete, it also shows me, okay, do you understand the task at hand? And I can double check and make sure that they're on the same page for understanding how to find the perimeter and the area of these shapes. So that would essentially be the lesson. Obviously it would take a little bit longer if we were doing it in front of students here. Let's talk about differentiation. How could I differentiate this for other students? So dependent upon the caseload and their individual needs, definitely calculators could be something that they could access and reference if it were needed. Especially once it gets more into multiplication of larger numbers. A calculator would be a great resource for students to have. And then also, especially for students that struggle with reading comprehension, maybe they're not solving that word problem by themselves, right? So whether that's with me instructing, working one-on-one while the rest of the students that are comfortable doing a small word problem are doing that, or maybe lessening the words there and just telling them, okay, you need to solve for a perimeter, here are your lengths, how can you solve for a perimeter? So they're still showing what they know, and I'm able to check for understanding, but it kind of takes out that piece of reading. One last thing that I would definitely do, I do it for my whole class right now, but regardless of student needs, depending upon, is providing them with a visual. So this formula sheet would be a great visual for them to have, just to first off remind them of formulas that they need to know. So that's what I would do. That's how I would differentiate, and I hope that you enjoyed my video. Thanks.